Hello and welcome to our first virtual coronavirus lecture. I'm going to try to make this as clear as I can, and since this is the first time we're doing this, I'm going to point out some features of these little virtual lectures as we go so you know how to navigate the rest of the Canvas course structure. Also bear in mind that I have a cold and so my voice has been affected by it. Hopefully that'll get better soon and I won't sound so horrible. But it is only a cold. I did go to my doctor. I do not have COVID-19, so rest assured. So why don't we begin and go through some things about Cosets. This is the narrated version of the online document. So if you ever have any questions about anything as we go through this, you can post them to the question board. There's a link to discussion for Cosets Part 1. Any question about this handout should go to that discussion board and I will answer it, or a colleague can answer as soon as I can. As we go through these handouts, you might see some exercises for you to do to reinforce your learning, and those exercises should be done on paper and then post your answers to Canvas, and Canvas will grade it and let you know how your understanding is. So let's start and talk about Cosets a bit. We've already gone through the first page of this handout. It looks different because I reformatted it, given our new format here. So we've already talked about what a left coset is. You start with a mother group G and you fix a subgroup H, and once you fix the subgroup, you get cosets. And on the left, we have cosets look like an A times an H. An A is called the tag or the representative of the coset, and it's just a subset of G. And as we said before, it's like H, but it's been translated by a constant amount A from the mother group. And so we did some examples last time of what if you were in the simple group of integers, and H was all the multiples of 3, and then you get 3 cosets by scooting the original subgroup H, which is this guy right here. You can scoot it over once, scoot it over twice, but when you scoot it over 3 times, you come back around to H. And so there are only 3 cosets. And these cosets are exactly the congruence classes. So this says secretly behind the scenes, we'll see later, something to do with Z mod 3. Okay? And of course, our group operation is written with a plus sign in the integers, so we write our cosets with a plus sign too. We then looked at a finite example. So a finite mother, here Z mod 12. And H is a subgroup containing only 0, 4, and 8. So it's a cyclic subgroup generated by 4. And we mapped out the cosets, and we have 4 cosets. And each coset has the same number of elements, as Adriana pointed out last time. And then we did the same thing for a non-abelian group like D4, the dihedral group, which is the symmetries of a square, which has 8 elements. And we took H to be this little subgroup, R0 and FV, and it has 4 cosets. And every coset has 2 elements, just like H had 2 elements. And the size of the group is 8. And sure enough, the size of the subgroup 2 is 2, and there are 4 cosets, and 2 times 4 is the size of the mother. So the mother has size 8, the subgroup has size 2, and there are 4 cosets, and 4 by 2 is 8. Just for fun, we work on the right-hand side. In example 4 is what our textbook author would do. And if you work with the same subgroup H and the same mother D4, you get different cosets. Here, the one for R90 has the northeast flip, whereas before the left coset for R90 had the southeast flip. So the individual members are different, but they still have 4 cosets and still 2 elements each. So some things didn't change, right? So although the individual elements changed, the counting structure did not. There are 4 cosets here on the left, and there are 4 cosets here on the right. Everyone here had 2 elements. Everyone here has 2 elements, albeit different. Your first exercise is to redo this whole story where the mother group is D4, and the subgroup is instead declined 4 groups. So the subgroup containing R0, R1, 80, FV, FH. Compute all the left cosets of H and D4, write them all out. Do it all over again, start over, compute the right cosets for H and D4. What do you notice? Okay, now there is an associated Canvas quiz that's linked to this handout that has only one question in it because there's only one exercise in this handout. Go to the quiz when you feel comfortable getting the right answer and type in your answer. It's a free form text box. When you submit it, I'll get a flag from Canvas that you submitted it, and then I'll grade it. Okay? You can take that quiz as many times as you want until you get it right. This exercise and the quiz is the replacement for me and you having a conversation in class and you asking me questions. So the way I'm checking that you're tracking with me is I'm checking your answers in these quizzes. I'm calling them reading quizzes in Canvas. They're going to count for a grade, okay? You can do them as many times as you want. That's the analog of you asking me a question 10 times in class until you understand it. I don't care. I will regrade it until you get it right. Okay? So try that when you feel comfortable. Finally, today, we need to talk about how you actually work and manipulate cosets. Everything that you need to know, okay, to work with cosets is listed in Proposition 1, okay? I'm not going to read it to you. I will point out what it says. I will not read the proof to you. You can read it yourself. If there are things you do not understand about this proposition, if there are things you do not understand about its proof, that is the perfect thing to post to the discussion board. There's a discussion board calling for questions about this handout. Post your questions. I'm happy to help you answer them, okay? So I want to first point out that part 2 of the proposition says something that we already knew about congruence classes. And as I said before, congruence classes are a special case of cosets. Excuse me. So we're not shocked that this is true. Any two cosets are either exactly the same coset in disguise or they are completely disjoint. So cosets can never sort of halfway overlap. The proof is in the second paragraph of the proof below. Item 3 is probably the most important thing. It tells you how one knows when two cosets are equal, okay? Suppose you had a coset tagged by little a, and suppose you had a coset tagged by little b. How do you know they're equal? Well, it turns out they're equal if and only if A inverse B belongs to H. So it's very simple. You simply check if A inverse B lives in H. And the thing to remember here is that we are working with left cosets. And when you want to test if two left cosets are equal, you invert the tag on the left. It's A inverse B. A has the tag A has the inverse on it, okay? It's not AB inverse. If you wrote down AB inverse, you would be putting the inverse on the right-hand symbol. No, we have left cosets. The inverse tag goes on the left. Again, the proof of that is below. Items 4 and 5 are related to each other, so I will just explain item 5. You are sometimes going to be in a situation where your tag is itself a multiplication. So here I have a tag AX. You will often want to know when you can simplify that and suck that X inside of H. So here I'm absorbing that middle guy X into the symbol H, and I'm asking when is AX H the same thing as AH? So the X has disappeared inside the H, the capital H. You can do that if and only if X already lived in H. This is an important law. It's the law of absorption, okay? Please notice that's this special, item 4 is just a special case of that, okay? So this is an important thing because it tells you how you work with cosets and how you can simplify this complicated guy into this simple guy. So read this proof and ask questions. I'm sorry, as an errant click. Read this proof here and ask questions. It's not that bad, to be honest, but it's a little bit confusing. The proof will use repeatedly that H is a subgroup. H wasn't any old subset. It was a subgroup, okay? So H is closed under multiplications. H is closed under inversions. H is closed by having an identity element. It has the same identity from G, okay? Finally, I'll leave it to you to read these last 2 paragraphs. If you get confused about this, ask any questions. I think for now, you should try to read this handout, read it again, take the quiz, see if you get the quiz right. If you have questions, pose them to a discussion board, the one that's linked to this handout. And then if you're comfortable, go to the next one. There'll be a Cosets Part 2 coming right after this. It's going to be the same thing. And by doing this, we're going to get through this together. Okay, guys? If you have questions, I'm going to have virtual office hours In Zoom, you need not have a Zoom account, and it's free as long as you have a laptop where you can listen and have a microphone. This will work. So I will say more about virtual office hours later. We'll try to do it. We're all free at 10 o'clock Monday, Wednesday, Friday. Okay, so if you ever need me, you know I'm around then. Try it out, see how it goes. Let me know what you need. Take care and wash your hands.